Good morning, students. So we discussed about in a last class work, energy and power. So some problems on face that power. Okay, so the power is equal work by time, etc. We discussed in a last class. Today we discuss the another chapter. So that is called as a law of motion. Okay, law of motion. So in this chapter we study about what is the laws, Newton's laws, first law, second law, third law. What is the inertia and what is the force and so what is the inertia, impulse, momentum and so the friction is also discussed in this chapter. So what is the friction and how many types of the friction, how to define that friction. Okay, so the decreasing and increasing methods of using friction and what is the advantages, what is the disadvantage of the friction, so etc. topics discussed in this chapter. Now first of all, what is the force? Already we discussed in a last class. The force is nothing but that is called as a physical quantity. Force is a physical quantity and try to change the state or position is called as a force. Okay, so what is the force? So force is a physical quantity that try to change the state or position of the body is called as a force. The force is measured in a newtons and X. Okay, so already we discussed in a work, energy, power chapter. Okay, so now discuss the another topic, that is Newton's laws. So Newton's laws, Newton first law and second law and third law. Okay, so Newton first law. Every body continues to be in a state of rest. Every body continuous state of rest or a uniform motion in a straight line, unless completed or unless by or external force. Okay, external, there is no external force. Okay, when unless there is some external force to change that state, that means so the a body is moving along a straight line. Moving along a straight line. So every body is continuous to be state of rest or uniform motion. So every body state of rest. Every body in the universe state of rest. So state of rest or uniform motion. Okay, when there is no external force, when there is no external force is acting on the body. Okay, so that is called as a Newton's first law. So what is the Newton's first law? So the state, that means every body, okay, state of rest or uniform motion. State of rest or uniform motion. Okay, every body is a state of rest or uniform motion unless the force acting on the body is called as a Newton's first law. Okay, so similarly another topic, Newton's second law. So the action force is equal MA or F is directly proportional dP by dt. Okay. So according to Newton's second law, the force is acting on the body. The force acting on the body is directly proportional. So the rate of change of the momentum. The rate of the change of the momentum is called as a Newton's second law. Newton's second law, every body, the force is acting on the body is directly proportional. The rate of change of the momentum is called as a Newton's second law. Okay. Newton's third law. So that is called as a action. is equal minus reaction. Okay, action is equal minus reaction. So that is means so every body, so the force is applied, that is called as the action, is equal to the opposite reaction, is called as a Newton third law. Okay, so once again repeat, what is the Newton first law? Every body continuous state of rest or uniform motion. Uniform motion. So there is no external forces acting on that body. Okay, got it. So Newton's second law, the force is acting on the body is directly proportional. The rate of change of the momentum is called as a Newton's second law. So what is the Newton third law? So Newton third law, every body, the action on every body is equal to the reaction. So that is called as a, we can write. Okay. So now we discuss the another topic is a, what is the inertia? Okay. What is the inertia? So inertia is just like Newton first law, is a similar pattern. Okay, when there is no external forces acting on the body, so that is a continuous state or continuous uniform motion. Okay, there is no change of the state. Okay, there is no change of the position, so that is called as a inertia. Okay, got it? Inertia, Jadatpaman, inertia. Okay, so there is no change in the state of a rest or uniform motion when there is no external force is acting on the body. Okay, got it? That is called as a inertia. Okay, so the next one. We discuss about the momentum. Okay, so what is the momentum? What is the impulse? So what is the law of conservation of momentum? Give the some examples. Okay, so what is the momentum? So the momentum, it is denoted by the P. So P is equal mass into velocity. Momentum. Okay, so momentum. So momentum is equal to mass into velocity. Mass into velocity. So the product of mass and velocity is called momentum. Okay, so the momentum is defined as the product of mass. The product of mass and velocity is called as a momentum. Okay, so momentum units is taken. Units. So kg meter per second is taken units of momentum. And so what is the impulse? Impulse, it is denoted by the I or J, etc. Okay, impulse. So the impulse means, okay, the large amount of the force is acting on the body very short interval of time. The large amount of the force is acting on the body for a short interval of time is called as a impulse. So this is called as a chop. Is the large amount of the force is acting on the body. So change. Okay. So short interval of time. For short interval of time, that is called as a impulse. Okay. There is exchange of the momentum. Okay, so the impulse, what is the impulse? Impulse means very large amount of the force is acting on that body for a short interval of time is called as the impulse. Okay, so what is the law of conservation of the momentum? Law of conservation of momentum. So when there is no force is acting on the body, acting on the system. Okay, when there is no force acting on the system, the momentum of the system, the momentum of the isolated system, okay, isolated system of the containing of the particles remains constant. So that means there is no external torque, there is external force is acting on the body, is acting on the body. When there is no force is acting on the body, the total momentum of the system before is equal total momentum of the system after, we can write or the total momentum of the system. The total momentum of the system, isolated system, remains constant. So that is called as a law of conservation of momentum. So what is the law of conservation of the momentum? So the momentum of the before system is equal to the momentum of the after system. So the momentum of the isolated system, total whole of the system, is constant, remains constant when there is no force is acting on system. Okay. So now here there is an example is taken. So this is called as a mass of the body is m1 and so velocity is taken u1 and mass of the body m2, initial velocity is u2. Okay. After collisions, so mass of the body is m1 and m2, so velocity is taken v1 and v2. Okay, so now consider the two bodies, two spheres. Okay, so mass of the two bodies m1 and m2 and initial velocities is taken u1 and u2 before collisions. Okay, so we get the velocities v1 and v2 after collisions of the body. Okay, so according to law of conservation of linear momentum, according to law of conservation of linear momentum, so momentum of the system before collisions is equal to the momentum of the system after collisions. Momentum of the system before collisions is equal to the momentum of the system after collisions. So that means here m1 u1 plus m2 u2 is equal m1 v1 plus m2 v2. So this is called as a law of conservation of linear momentum. Linear momentum. So for example, is taken. So the gun is fired. Gun is fired. Okay. The bullet is fired from gun. The bullet is fired from gun. So MOV2 is equal to MOV1. Okay. So the gun, the bullet fired from the gun. Okay. So the force, so some external force, some force is acting on the bullet, that is called as a MOV1. Okay. And so the bullet is the fire from the gun. So the force is extracted on the gun. So that is called as a MOV2. So that means so MOV1 is equal to MV2 or MOV1 minus MV2 is equal to 0. The total system of the momentum is 0 or constant. Okay, got it. So first of all, so the bomb is at rest position. The bomb is at rest position. So the bomb is explode in two pieces. Okay, explode or explosion in two pieces. Okay, so that means m1 v1 plus m2 v2 that is equal to minus. The two pieces are traveling in opposite direction. Okay, so that is means the total. So the first of all, before momentum of the system is 0. Okay, because the body initially at rest. Okay, at rest position. That means the momentum before system is 0, and after system, after collision, after explosion, so m1 v1 plus m2 v2 that is equal 0. We can write the total system is equal 0, or m1 v1 is equal minus m2 v2 or m1 v1 plus m2 v2 is equal 0. So momentum of the system before and momentum of the system after. So that is called as a, according to, based on law of conservation of linear momentum. Okay, got it. Alright, what is the momentum? Mass into velocity is called as the momentum. So what is the impulse? Impulse is nothing but, so that is nothing but exchange of the momentum. When large large amount of the force is acting on the body for short interval of time is called as a impulse. Okay, so this is called as the best examples of the law of conservation of the momentum. So what is the law of conservation of the momentum? When there no external force is acting on the system, before system is equal to the, that is total remains is constant. Okay, the total isolated system remains constant. So when there is no external force is called as a moment of law of conservation. Okay, got it. So next one, what is the friction? So the friction is the force which oppose the relative motion between the two surfaces in a contact is called as a friction. The relative motion between the two surfaces. The relative motion between the two surfaces is just like so one body is the relative motion. The one body is taken, another body is motion. So that means the force which oppose, very important point, the force which oppose. So the relative motion between the two surfaces, the relative motion between the two surfaces in contact. The relative motion between the two surfaces in contact is called as the friction. When the two bodies are contact. Okay, when two bodies are contact, oppose the force, the relative motion between the two bodies is called as a friction. So just example, so the walk on a road. Okay, so the grip, that is means the chalk piece is placed in your fingers because due to the friction force. Okay, friction force. So the right on the board, due to the friction force. Okay, that means so oppose the relative motion, oppose the force, the relative motion between the two surfaces or contact. Between the two surfaces or contact is called as a frictional force. That is also force, frictional force. That is are applied between the two bodies are in contact. Okay. Now, so the frictional force, the frictions are classified or divided in three types. That is called as a, one is taken limiting friction. So next one, kinetic friction. Kinetic friction. So third one is called as a rolling friction or dynamic friction. Dynamic friction. So the limiting friction, kinetic friction or dynamic friction, and rolling friction. Okay. So what is the limiting friction? So the limiting friction means so the maximum value of the static frictional force, static frictional force, the maximum static frictional force. So one body or when two bodies are contacted and one body is tends to move, when body is tends to move and another body is called as a limiting friction. Limiting friction. So what is the limiting friction? So the maximum value of the static frictional force. The maximum value of the static frictional force when body is tends to or move to or another body is called as a limiting friction. Okay, got it. So the limiting friction, so that is called as the maximum value of the static frictional force. The maximum value of the, that means so just a small force is applied, that is the moved body. That means move to tends to on another body. Ready to move to the another body. Ready to move another body. So that is called as a limiting friction. Okay. The maximum value of the static frictional force. The maximum value of the static frictional force. That means so for example, is taken one body on surface. So the small force is applied, the body is not moving. So some another force is applied, the body is not moving. So the maximum value of the force applied, the body is moved to ready to on another body. Okay, ready to move another body. So that particular value of maximum frictional force is called as a limiting frictional force. Limiting frictional force. Okay, got it. So for example, so one bag is taken on a surface. Okay, so the bag is lifted. So small force is applied, the body is not lifted. సో ఇంకో కొద్దిగా ఫోర్స్ అప్లై చేసాం, బాడీ నాట్ లిఫ్ట్. ఇంకో కొద్దిగా అప్లై చేసినట్లయితే ఆ బాడీ అనేది లిఫ్ట్ కావడానికి రెడీగా ఉంది. సో దట్ ఈస్ కాల్డ్ as the maximum static frictional force is called as a limiting frictional force. Okay, so what is the kinetic friction, what is the dynamic friction? So what is the dynamic friction? When the two bodies are contact to each other, when the two bodies are contact to each other, so one body is slide over to the another body, one body slide over to the another body. So this is called as a one surface. So the body is taken sliding body. Okay, that is sliding body. They oppose the frictional force, oppose the frictional force or oppose the encounter force, oppose the frictional force when the sliding body to on another body. When these two bodies are contacted, oppose the force is called as a kinetic frictional force or dynamic frictional force. Okay, so now another is taken rolling. So the rolling friction is also same. That means so one body is rolling to another body. Okay, oppose the frictional force between when two bodies are contacted. So that is called as a rolling frictional force. Got it? So what is the limiting friction? So the maximum value of the static frictional force is called as a limiting frictional force. And so what is the kinetic or dynamic? So one sliding body is slide on another body. The force, the kinetic, that is means the opposing the force between the two contacts is called as a dynamic friction. So what is the rolling friction? So the rolling, one body is rolling to the another body. Okay, one body is rolling to the another body. Okay, so the oppose the frictional force between when two bodies are contact is called as a rolling friction. Okay, got it? Right. So next one, that is called as a mention decreasing friction using methods. Mention decreasing frictions using methods. So the first one is taken. Okay, so polishing and so is the other taken is called as a, okay, so polishing lubricates. So third one is called as a, so ball bearings and so fourth one is called as a streamlining. Okay, streamlining. So that means polishing. So polishing means so what body is polishing. Okay, polishing. So when very smoother. Okay, so very smooth. That means due to the friction will be reduced. So by using the one of the method using the polishing. So polishing, when body is smoother, the frictional force is reduced. The frictional force reduced due to the polishing of the body. So polishing is the one of the best method. So the decreasing of the frictional force. Okay. So now next one is the use to lubricates. What is the lubricates? Like grease, oil, okay, etc. are used lubricates. Okay. So what is the lubricants? Grease, oil, okay. So the etc. are used engines decreasing of the frictional force. So by using the lubricants method. Okay. So now another method is taken, ball bearings. So ball bearings is means so the two bodies are sliding bodies. These are two bodies are sliding bodies. The sliding bodies between the is ball bearings are applied. Okay, so the sliding friction is converting. The sliding friction is converting to the rolling friction. Okay, the sliding friction is converting to the rolling friction is called as a ball bearings. Okay, so ball bearings are used to reduce the frictional force. Okay, when two bodies are sliding bodies, so the ball bearings are the ball steel, that means steel balls. Okay, the steel balls, the steel bodies is placed between the two contacts, between the two sliding bodies. So the sliding friction is converting to the rolling friction. So that is the reducing of the friction. Okay, so that means used. Now another is a streamlining. Streamlining means so the aeroplane or automobiles special designed. Okay, so because that is called as a the streamlined airflow means so this is called as a streamlined airflow. So this is called as the air streamlined flow. That means so the reduce the due to the air friction. The friction is reduced due to the air. Okay, so that means the line of the streamlined flow, that is air is streamlined flow. That is aeroplanes or automobiles special designed because the frictional force is reduced due to the air. Okay, so the air is flowing, that is the streamlined. Okay, streamlined means dara rekala pravahanga velutundi. Streamlined flow, that is called as it. Due to the frictional force will be reduced. So the friction decreasing by using the four methods: polishing, lubricants, ball bearings, streamlinings. So the four best methods are used to decreasing of the friction. So the polishing, so the two bodies, when the polishing on another body, so very smoother and so reduce the friction force. Lubricants, oil, grease are used. Ball bearings, so that is means the steel bodies are using the sliding friction is converting to the rolling friction, that it will be reduced to the frictional force. And also streamlining means the air streamlined flow reduced due to the air friction. Okay, due to the air friction, automobiles, aeroplanes are used to special designed that purpose. Okay, got it? Right. So now discuss the another topic that is called as a. So what is the uses of the friction? What is the advantages and disadvantages? Okay. So and one roller body. So the roller is taken. The pushing and pulling is the best easy method, pushing or pulling. Okay. So that also prove that next class. Okay. Thank you, students.